In this tutorial, we shall show you how to use the different symmetries available in Dplus. Assembly symmetry defines how repeats of a subunit are arranged in space. In other words, the symmetry defines the translations and rotations of all the repeats of a subunit. In Dplus there are three kinds of symmetries: space-filling, manual, and scripted symmetry. For example, we select as our subunit a simple uniform sphere with a radius of half a nanometer. We start by placing our sphere model in a manual symmetry. In manual symmetry, by adding new layers, we can add as many instances of the subunit as we wish. Each layer is an instance of the object in the manual symmetry. In this example, the instances are of a simple sphere model. Here we demonstrate how to change the X position of our three sphere model instances. Instead of manually entering the locations and orientations of each instance of the subunit, we can create a text file called a DOL file with the locations of every instance in X, Y, and Z, and the rotation angles alpha, beta, and gamma. Alpha is the rotation about the x-axis, beta is the rotation about the y-axis, and gamma is the rotation about the z-axis. Now we place the same sphere as before within the manual symmetry and we load the layers from the DOL file. As always, to find the relevant integration parameters, we envelop the entire object by an appropriate geometric shape. This time we are using a symmetric slab model. We then insert its dimensions to suggest parameters and use its suggestions in the Preferences pane. We chose Monte Carlo integration, grid size of 30, and we click Generate. In the resulting scattering curve you can see a very weak peak related to the correlation distance between the spheres. Because we only have 7 repeats of the sphere, this peak is very weak. We will now show how we can create the same hexagonal symmetry using space-filling symmetry. We shrink the spheres to make it easier to follow in the following steps. We then add an extra sphere. The old spheres are red, and the new spheres are green, because their electron density is different. The green sphere is then placed within the so-called space-filling symmetry. In space-filling symmetry, you have 3 vectors. In each vector, you define a repeat distance, an angle, and the number of repetitions, and this defines the entire symmetry. In the user's manual, you will find full explanations of these parameters. Here we created a hexagonal symmetry with 2 repetitions in each of the first 2 vectors and 1 in the third vector. All in all, we have overlapping 4 spheres from the manual symmetry. In space-filling symmetry, it is very easy to change the number of repetitions and to increase the size of the entire structure. We are now moving it around a little bit using the symmetry editor so it is centered close to the origin, and we see that we have a full overlap with the manual hexagonal lattice. Now we are increasing even further the lattice. To get faster and more accurate results, it is always important to make sure that your object is centered at or near the origin. Again, we add a slab model to estimate the size of our object, and use suggest parameters to find the relevant parameters. After we enter the suggested parameters into the Preference pane, we click Generate. Look at the bottom left corner of the screen, where the progress percentage is written. The first 30% of calculation is the computation of the grid. This computation takes a while because it is a fairly large grid. On a GPU, this is very efficient and therefore much faster, as you will see in the following tutorial. The rest of the computation is devoted to orientation averaging, and because the object is nearly two-dimensional, the amplitude is localized in Q space, causing the orientation averaging to be slow. Now you can see that because we have more repetitions in the lattice, the correlation peak is much sharper and stronger. Just to show the simplicity of the symmetry, we enlarge the size of the lattice even more. As always, we ensure the entire object is centered.